Okay, here is unit circle part 4. Lastly, we talk about the tangent ratio. So we've been talking about sine and cosine a bunch and how to find values of that. So hopefully you're familiar. Um, so there are two ways to think about the tangent. One is tangent is or equals sine over cosine. And it's sort of simple to prove this by saying sine is the opposite over hypotenuse and cosine is the adjacent over hypotenuse, and dividing by a fraction is the same as multiplying by the reciprocal. So if we actually were to divide this by this, the hypotenuse part would cancel out, and we would have opposite over adjacent, which is tangent. So we'll start with that. Tangent is sine over cosine. So if you have a situation such as this, all right, our angle is pi over 3, which is 60 degrees. So 60 degrees, pi over 3, and we're interested in, well, what is the tangent of 60 degrees? What is a tangent of pi over 3? So you can think, well, I know that you go through the thinking you already did, where this is 30, 60, 90, so 1/2 root 3 over 2, and what we would end up with is that the tangent of pi over 3 is equal to the sine of pi over 3 divided by the cosine of pi over 3. Sine is root 3 over 2, cosine is 1/2, and root 3 over 2 divided by 1/2 is the same as root 3 over 2 times 2 over 1. These cancel and we get square root 3. So that always works, and sometimes when I teach this to students, that's as far as I go, and I say, alright, so because that's as much information as you need to know and you can do it. This can be tedious and involves more steps where you might make a mistake, so there is another way to think about tangent. So let's say we have some practice here. Let's do this because this will be good practice. So pi over 6, how many degrees is that? You're probably thinking 30 degrees. That's good. And so 30 degrees, we draw a quick little triangle. 30 degrees, or pi over 6, and so we know the sine is going to be 1/2, and the cosine would be square root 3 over 2. So if you don't really know how to get those yet, you should probably re-watch part 1, 2, and 3. But if you get that, great. Tangent, then, we just say sine over cosine, so 1/2 over root 3 over 2, and dividing by a fraction, same as multiplying by the reciprocal. I'm skipping a step there, and so the 2's would cancel, and we would get 1 over square root 3. If we were talking about 2 pi over 3, let's see, 2 pi over 3, so 2/3 pi, that's here. These are thirds. 2 pi over 3. Here's our little triangle. So we would have that the sine is root 3 over 2, and our cosine is negative 1/2. Therefore, in finding tangent, we would do sine divided by cosine. So I'm going to skip that step and multiply by the reciprocal. So we have negative 2 over 1. So this is giving us negative square root 3. When the 2's cancel, don't forget about the negative. Root 3 over 1 is root 3. Pi, let's see, we'll move down here. So here's our angle pi, and we know that the sine, the y-coordinate is 0, cosine, x-coordinate is negative 1, and let's see, sine over cosine. So for this, sine over cosine, 0 divided by negative 1 is 0. Okay, and lastly, 7 pi over 6. So we're looking at this. 7 pi over 6, we have all our sixths up here, like this. And sine would be negative 1/2, and cosine would be negative root 3 over 2. So tangent, we do Sine divided by cosine, which is the same as multiplied by the reciprocal. Our negatives cancel, 2's cancel, and we end up with 1 over square root 3. Okay, so that always works, and for some of you that might be enough, but there's kind of an easier way to even think about this. So think about the word tangent. You learned early, so in geometry, that tangent to a circle is a line that just crosses the outside. So this would be a tangent line to our circle. And if we think about our unit circle with this line over here, so this is our y-axis, this is our x-axis, right? So this is up at 1, this is up at 2, this is over x equals 1, this would be x equals 2. This is our origin. And take a look at what happens. So the tangent, just like when we had this, right? Here's our terminal point. If this is our angle, we said that the x-coordinate is the cosine and the y-coordinate is the sine. We can do something similar and look at the terminal point. Look at where our angle line crosses the tangent line. So let's see how this works. If we talk about this, so 30 degrees or pi over 6, we're talking about 30 degrees, same as pi over 6, we would say that the cosine is root 3 over 2, we would say the sine is 1/2, but if we extend this out and see where this actually crosses, so that distance is going to be tangent of the angle. And in this case, it turns out to be 1 over square root 3. If we look at 45 degrees, so I'll color code, and hopefully this doesn't get too messy. If we look at 45 degrees, so 45 degrees, which is also pi over 4, the tangent ends up crossing this tangent line at 1, and it turns out that the tangent of pi over 4 is 1. So if we were to look at sine divided by cosine, root 2 over 2 divided by root 2 over 2 gives us 1. And then the other angle we could look at here, color code. The other angle we could look at is 60 degrees. So we've got 60 degrees, which is the same as pi over 3 radians. It turns out that the tangent, so where this crosses, this looks like about 1.7, which is good. Tangent of pi over 3 ends up being root 3, which is like 1.73. So this ends up being about 1.73. The 1 over root 3 is 0.577, and this is 1 right here. But there's another way to think about it, and it works with positives and negatives as well. So if I were to, let's take a look at a different angle, like, how about, let's get a different color. What if we were talking about this? So you're thinking to yourself, I wonder what that angle is, right? We're talking about all of that. And hopefully you thought to yourself, that's 135 degrees. Where am I writing this? 135 degrees, which is the same as 3/4 pi, so 3 pi over 4. And that line, if we move it out here, it's not going to cross, but if we extend it back, it is going to cross. And holy moly, look at that. So yes, the tangent of 3 pi over 4, or 135 degrees, is -1. So these are negative values, these are positive values. So this will work, let's say, for 7 pi over 6, right? It would be the same thing as this. And, oh yeah, one last thing. Two last things. So let's look at, in green, let's look at this. So what's the measure of this angle? Yes, you're right. Thank you. That is 180 degrees, or pi radians. So obviously if we go this way, we're not going to intersect the line, but if we go back, So if we extend the line backwards, we end up hitting the line right here, which is at 0. So verify for yourself that tangent of pi radians is 0. Tangent of 180 degrees is 0, so that works. And then the last thing would be something like this. So this, or this, same thing. So that angle, 90 degrees, so tangent of 90 degrees, which is the same as tangent of pi radians. Whoops, I didn't say that. Pi over 2 radians. And if we go like this and continue, or go like this and continue, it never hits this line. So that means there isn't a value. So this is undefined. Undefined. Alright. And before we move on to the next page, let's just talk about why that is. So why is the tangent of pi over 2 radians undefined? Does not exist. So let's see. It would be the sine over the cosine, and if we're looking at the sine of pi over 2 radians, that would be 1, and the cosine of pi over 2 radians would be 0. Aha! Notice how we're dividing by 0. That is not allowed. So, undefined. Cool. So, yes, you guessed it. More practice. So, we've got angle, we've got tangent, angle, tangent, angle, tangent, angle. And you might be drawing pictures. So, why don't you pause right here. Don't you dare just sit here and watch me solve this. So pause, solve them out, see what you get, and then I will show you the answers in a moment. So pi over 6, we had 1 over root 3. Pi over 4 is 1. Pi over 3 is root 3. Pi over 2, undefined. 2 pi over 3. Let's get a little skinnier marker. Excuse me. Okay, so 2 pi over 3, that would be like this, and like that. Okay, so this is going to be negative root 3. 7 pi over 6, that would be right here, which would extend back, and so that would be 1 over root 3. 3 halves pi, so let's see, 3 pi over 2, that would be 1 half, 2 halves, so 3 halves right here, which is like that, never crosses, undefined. And pi, right here, so that intersects right here, which would be on that tangent line at 0. Okay, so 2 ways of thinking about the tangent ratio using the unit circle. And notice how we did all of this without even touching our calculator. Pretty cool, pretty cool.